Hello guys, welcome back. Today we will introducing usually Python to do some machine learning, especially focus on the deep neural network. I'll give you a very basic example, which is come from the TensorFlow official website. I will show you use just very few lines that you can train your machine to recognize image and give you some answer. So from there you know the basic concept of this machine learning or this deep learning network. First of all, we always import the TensorFlow as a TensorFlow. This is a traditional way, like we always use PD, refer to pandas, use NP, refer to the non-P. So TensorFlow, traditional way is TF. You can go to the other one for sure. In here, we will just introduce this keras. TensorFlow is a core function of the machine learning of the deep learning network, and all the algorithm is running in a TensorFlow. That's not easy to use. And Keras, you can think about is just an API to wrap TensorFlow. It's running on top of the TensorFlow, but provide you a very provide the user, especially for the beginner, very easy API to call the TensorFlow core function. So basically, you think of TensorFlow is a core, while Keras is a UI facing to the our final user here, right? And this is next is a test example, which can be downloaded from TensorFlow official website. Yeah, including the training feature and the label. Also for the test training and test feature and test label. So you can download it and then use it to run a few lines to verify how to run your own very simple deep learning program to let your program can training and then recognize the image. So maybe you already for basically you know that we just use x and y. X usually refer to the feature or character, and y just need a label, right? For example, how can you know the animal is a dog, right? So for example, yes, 4 legs, yes, 1 head, yes, 1 tail, and then you can at least to distinguish the dog from the bird, right? Bird only has 2 legs. So here, how many head, how many legs, what color of the skin? This is the kind of the character or features. But finally, we label it as the dog. So traditional way, again, usually we use the X. Usually should be capital X to refer to the features. Features can be array, right? Usually we use NP array. It's a list of different features like the color, like the leg, how many, also the color of eyes, for example. And Y just means the label. Finally, you give it a name. What's the name of this animal, right? So this one is for training. Usually you should reserve about the sample. Usually you can at least reserve about 30% reserve the test, right? So training just this program we are running on top of it to optimize this algorithm, optimize this parameter, and finally give you a model. Then you use your model to test and then input your test X. Then the model will help you to predict the test Y, which is the label. Then you compare with the real Y. Then you will know what's the accuracy of your model, how many loss it is. Then you can do an average to average to find out how good the model it is. So you will know you will continue using it in production, or you maybe you just abandon it to retraining another one. Okay. So here we just go to here the command enter. You will go to the official website to download the data, and then finally you will save it to the F train and Y train. And we can take a look at what kind of the X it is, right? So you can see this is array, right? This is a three-dimension array, right? This is one dimension, this is second dimension, this is third dimension, and then we can know Y. Y is also an NP array, but here's just a label here. You can see a number, right? This is INT 1 byte, and this number. Basically, I can show you here. This actually it is an image. It's an image. Then you represent to 5. Right? You may know that the image in the computer you just save as a pixel. Each pixel has a position, and each position has a color, right? So you just use two dimension. You can represent the image in the memory of the computer. And here is about 60,000 image layer. So that's another dimension. Just mean how many images in this list, right? You can see here, return, you can use shape. So you can see each image is 28 pixels multiplied to another 28. So also inside the number just mean the color, what color it is this one. So how many image in this list? There's about 60,000, right? So one train should be the same number, because it is a label, right? So you just use one number to represent the meaning of the X. What's the meaning of the image? And how many is totally against 60,000 here? So we can also see X test list for testing. Let's see. So testing, we just use tensor. So here just about let me every 6 training we use for one testing, right? So the ratio is 6 to 1. But again, here is the pixel should be the same. Basically, training and testing, they should have the same feature, similar label, same label actually, but only the different quantity. Training usually has more, and like 2 times, 3 times compared with the testing, the set, right? So again, we use training to train the model, then input this test feature to predict Y, then compare with the real Y, then we know that the accuracy. If the accuracy is okay or match your requirement, then finally we can use this model to apply to production. Okay, and now we just want to do one more thing. As you can see here, at train, I can show you more detail here. At train, we can just take a some example. Like I say, here's about 60,000 quantity. So you can see this is one of them. This is second one because it begins from 0, right? So you can see a lot of number here. Each pixel, remember, this is the data is united INT 1 byte, so maximum is 255, right? So you can see some number is big, some number is just 0. If you have this one, that means usually this mean color, right? I'm not sure. This also means if value higher, that means it's darker. So 255 maybe just mean the black, while 0 means this pixel is white color. At least another number should represent the other color, like a yellow or like a red, for example. And so, and we can do one more thing. Let me see. How can I want to show you what's the number, what's the image, real image it is. Let me find out. Just give me 1 second. So so we can import the coordinate plot lab. This one you may already know that this is just very good. Which is also the standard Python library to the module to if you want to draw a graph or visualize something. So we can use this one. So let's see. So this is we always see why it doesn't matter because all is about 60,000, right? So they see a different if we use input this pixel array to this plot, then we just show it out. This is just a plot function to how to show you a 2D image, right? You can input 2D image data. This is the data. Then it will just show you the output here. You can see this is the 0, right? So this is never we can just verify it. For example, y train, then also 1. This is 0, right? Just like I said, this is the label. So we can again, for example, we try to 5. Then this should be 2, right? So let's try to 5. That should be 2, right? So here you may get some idea. Initially, when we really do it, we need to add one more parameter. This is array. This is you can see different. One colorful, one's only the black and white, right? Because for sure, colorful it's beautiful, but you need to consume more CPU, more RAM, more computer resources, right? So black color and black or white color, you are not so beautiful, but you save the computer resources. But in our case, the purpose is just to recognize what's the meaning of this image, right? But as we know, this shape is much important compared with the color. So that's why we only need to keep the shape information to save the result. It doesn't. I don't think this will impact our accuracy, right? So when you learn more in machine learning, you will know that the algorithm is always the same. But the key thing is you need to optimize some parameter to get more accuracy and also save the results, because usually the deep learning program always need more results, need more time, right? So here we'll do another thing, try to save to speed up. Remember that a lot of the over 1 in your X, right? Remember? A lot of the number is greater. Like 255 is the biggest one, as something 200 or 100, for example, right? So this number is okay, but when you use for the machine learning training, you are much slower. You slow down the computer speed. So usually we should use called the normalize, right? Normalize, what does it do? You do a mapping. You're mapping different range between 0 and 1. So mapping all number to series range. I just take an example, it's not real scenario. For example, 255, you can map into 1, right? So in this case, 255 equal to 1. So 124, which is almost half of 255, it may map to 0.5, right? So basically, no matter how big is the number range, right? Always mapping to one-to-one mapping to the between the range 0 and 1. And this is the math operation. I don't know the detail, but the concept should be the same. The reason why we need to do that because the algorithm training, if you change it to the 0 to 1, then the running speed will be much faster. The accuracy still be the same. No matter you do the normalize or no, accuracy always be the same. So you will not impact the accuracy. For sure, if you do this one impact the accuracy, you will be the same. Right, so here I just okay, and now we will do the other one. Pick one more time. Now we just do to see what's in the this actual GL right now, you can see control this number through like this one number maybe about 255, now change to the 0.3, 0.5. Again, all the number is between 0 and 1, but because we do a mapping, and so maybe you can see a lot of number behind the decimal here, right? A lot of number behind the decimal here, like 42 or 25, for example, a lot of number behind the decimal. So we do a mapping here. Again, here if you want to know more detail of this normalized doing, you can just search it. But usually, as a beginner, you can just call it. It should be much easy for you to begin. Okay, now after that, we should begin to add a module. So far, we already handle prepare the data which is ready to free training, right? We do the data download and data normalize. Then we finish the preparation. Because this is a test example, so data preparation is easy and fast. And when you in production, a real scenario, sometimes the data is not so organized. You need to spend a lot of time to do some preparation, like get rid of the GL number. Some number is infinity, some number is garbage. You need to delete it and organize it. Later, we can have another video to show all the detail. But for in this video, we can just keep it simple, right? So now let's continue to build the TensorFlow module. As you may know, that regular way, the TensorFlow just built by different layer there, right? So that's a very basic module. It's called sequential module. The meaning just means I just put a layer one by one. Like I build a 3 layer, layer 0, layer 1, layer 2. So the training data will go through layer 0 first, be handle layer, then send to layer 1, then send to layer 2, finally go to the output layer, then finally provide the result layer. For sure, there's a lot of other architecture, but sequential is the most popular and is very good for as a beginner. The second one is let me just to add the layer one by one. This is the module is architecture, meaning this layer should be sequential. Now we just add the layer one by one. This should be the first layer. Because we need to do some flatting. Because this input for each element is just 28 by 28, right? It's a 2-dimension the array. But unfortunately, the layer I show you later is called dense layer. This layer only can support the flatten. What means flatten? That means you need to change the 2 dimension to the 1 dimension. For example, it's a 3 times 3, 2 dimension. Then you need to just scan it, put it instead it's a 9, 1 dimension. So you just do a 28 multiply 28, change it to the 1 dimension array, then input to the second layer, which is called dense layer, right? So this one should usually suggest to do this way, and then dense layer just like a full connection with a full mesh, right? So it has a full mesh to the previous layers. They also have a full mesh to the following layers. So you can just like a real nature network. You can just full mesh. As you have more connection layer, the module may be more accurate, right? So here activation just some function. Again, here's a more popular called ILU. This is algorithm help you to do some data handling when the data transfer from one layer to the other layer. And I don't know this detail in the math, but usually this ILU should be very popular. I saw a lot of training, they just use this one. Some people say in the machine learning, data is more important. But how you, what's the activation, what's the algorithm is maybe it's not so important. You can always use a popular one, but you need to change some parameter. Then you keep training it and training again, and finally get some result. If a result is not good, you can go back to try another one, right? Maybe change the other algorithm, and because no people know which one how to select unless you see the result. So once you see the result, then you can go back to change your parameter. Okay, but in here we just give you an example, so we will continue. Also, each one has more layer, right? Not only one layer, and more layer just more similar like our human being brain, right? So we have more accuracy. Usually, we should do that way. And finally, this is the output layer. Output layer we cannot because here, just like I say, each image represents one number. Number is from 0 to 9, right? So totally output is output 10. And also this function in Google yet. My understanding is this one will output some just like some classified algorithm, right? Like U2, that means you classify into like 10, the output is 10 classified. This is also very popular when you try to label is classified, and then usually we use this one. Okay, here just some very basic function. If you want to know more detail, you can just Google it for each one. Here I just give you an example how you can just based on image to recognize the number inside it. But finally, you need to compile. You need to compile, right? So compile. Compile just means to help you to speed up the learning. So you need compile, and also this will check if any error when you build this architecture, right? Compile is define how the architecture is. This is built in the memory, in the RAM, build out the architecture. Then finally you can ready for to train it, right? So again, optimize is add-on. This is also popular. The reason I don't know, but I see a lot of people use this way. And this one also is just like classified. Because finally, the result is classified. So here just loss and accuracy is the most important output when you training a data, right? For sure, you want a lot to be lower. Accuracy should be higher. That means your model is good. If you go to object way, no, loss is the most important. It's not too high. Even accuracy is good. So maybe you just overfit it. Maybe you just testing it good, but when you apply to the real production, result may be not good. So loss is number one important. Accuracy is number two. So here you define how you want this, how you measure which algorithm to measure your loss, right? So okay, let's go. One is just some feature learning, we don't care about it unless you feel some error. Okay, now just to begin to do our final training here. So here just we, like I say, I input a training feature, also the training label. So you do a training, import training to how many types of training, right? When you go through all the training, then you will begin again with all the same input. Go to second, then repeat 3. Usually more approach usually mean more accuracy, but maybe not all the case. Later on, you can write a program to compare, like you equals 3, 5, 10. Then you compare the loss, compare the metrics. So you will see how it will be good or not. Okay. So here actually maybe take some time. You may heard that usually TensorFlow is running on the GPU, right? Because this calculation is not complex, but you need to repeat time and time. So GPU usually suitable for this kind of work. So if you have very good video graph card like from the Nevada, then you can run much faster. In my case, I running over a virtual machine. Virtual machine usually don't have the dedicated real GPU, so you only rely on the CPU. So for this, it's still be kind of okay because we don't have too many sample here. But in production, when we have 1 billion, then GPU will be much faster, right? So in our case, we can only use the like the how can I say like a CPU to do that. One of the ways is edge top, right? Edge top just means to monitor your CPU. You can see I have 8 core CPU, so you can see when this training going on, you can see all CPU begin to spike. So you will know that this one is also called some multiple processing. So you can just to running the task in multiple CPU layer. Okay, now we finish our training anyway. So now we're going to do some average. Remember here we just to train our model, not already training, right? So we can just to average. So we input the test training feature. Then your model will predict the Y label and compare with the real Y test. So you will know how many loss, how many accuracy tests. So let's see what's the output here. So you can see here loss 0.08 is pretty good. And as long as I see lower than 0.1, my point of view is okay. It's very good. Although the accuracy is 97%, very good. That means you give me 100 image, you correctly select 97. So it's very good here. Now also you can see this training takes a lot of time, right? But the verification just very fast, right? So that's why we can use this TensorFlow in production. For example, if in future you want to use TensorFlow to predict some stock or critical currency price, then you training take a long time, like 1 day or 2 days. But if after training you get a model, then you can use the model to use real-time data. Or when you input the real-time data, you can give the result right away. Otherwise, if you give in the stock, it give you the result also after 10 days, then you cannot use it for production, right? So that's the beautiful thing of the this machine learning. Training takes a longer time, but predict is very fast. Okay, I think let's we can here we can use to see something. So here is the loss. How many loss when you test with the tester set, and how many is the accuracy, right? It's 97, right? Only now usually need to save this one to module. We can give a name and give it a surface. Then the reason is that you don't only want to use this one once, but if you find out this is so good, you may ready to apply for the production, right? Then in production, you don't want to do training again. Training takes a longer time. So we can save it. So when you're in production, you can simply load it. Then you see a predict layer, right? So usually you find a good module, you will save it. Now we can just give you an example how to load it, right? So here we just save as this number. Then we define a new model. Then we just load it from the same file name layer. Then finally, then we can use this one to do some predict. Okay. So how do we predict? This is one way. To evaluate. And also you can just do predict one by one. For example, I want to predict 4. Right? You can either to input the whole list or single element. In our case, I just input this single element to give you an example. So I only predict this one. Sorry, I cannot input single element because it care about the shape. Let me see what is list on end of range. Let me load it again. Then we will see what's inside the test. Test is here, right? So test is good, but why this module has some error here? Let me try again. Okay, that's okay. Yeah. Sorry, I think this is because the predict need to care about remember the module here we define the shape, right? So maybe that's why you need to input the whole list instead of the element, because when you input element, it will be two-dimension array. That include a lot of things. A list that will be three-dimension, right? Okay. Now anyway, let's see the result. You can see result is something you don't know, right? Even the first one you don't know, right? But remember, this is just offer the possibility. Let's remember we offer about 10, right? About 10 possibility. So here represent 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So here it just means this is the first 0 means first image possibility, right? So you have so many possibility to be the 0. So usually you see which one is highest. So this one is highest, right? So 99% is highest. So usually this should be 0, 1, 2, 3, 4, 5, 6, 7. So I think this number should be 7 because this is the highest possibility. We can use the use one thing which is this one. Okay, let me import. Yeah. This is a non-P function. This is called argument. Let's just input this. They will just give you this whole list. Then you give you the most possibility. What's the number it could be? So like I say, this should be 7. We can also to give you verify again. So here we will just go to the text, right? Here we just result. Let's see what the real is attack. You can see it's really 7, right? So that means this prediction is correct. Image is 7, a output possibility, and find out the 7, the possibility is highest. So you predict this is 7, which is correct. Okay, guys, I think let's review for today, and we will continue with the other video and to show you more detail and how to use your production later on. Thank you.